Let f of x equal 3x plus 2. Then if we evaluate f of negative 1, we simply want to copy the f function, but when we see an x, we're going to replace the x with what's in parentheses, in this case, negative 1. So we have 3 times negative 1 plus 2. That is negative 3 plus 2, or negative 1. In example B, we have f of x plus h. Here again, we are going to copy the f function, but we're going to replace the x with what we see in parentheses, x plus h. And then simplify. We get 3x plus 3h plus 2. Now let g of x equal 4x. Recall from earlier that f of x is 3x plus 2. We now want to evaluate f of g of x. We can think of this as f of g of x, where the inner function is g, the outer function is f. So f is on the outside, so we're basically going to copy f, but replace x with what we see in parentheses, g of x. So replace the x with 4x plus 2. This will give us 12x plus 2. In part D, we want to evaluate g of f of x. We can first rewrite this as g of f of x. And now notice that g is on the outside. We're basically going to copy the g function, which is 4x. But instead of writing the x, we're going to replace the x with f of x. That is 3x plus 2. And then simplifying this, we get 12x plus 8. Earlier, we found that f of g is 12x plus 2. Let's evaluate f of g of negative 1. Since we have f of g, we simply need to plug in negative 1. This will give us negative 12 plus 2, or, when simplified, negative 10. An alternate way to attack this problem is to think of it as f of g of negative 1 equals f of g of negative 1. Here, if we write it as two separate functions, f composed with g, we can start with g of negative 1. Remember that from earlier, g of x was 4x. So that is f of 4 times negative 1. That is f of negative 4. And now we're evaluating f. And again, from earlier, f of x was 3x plus 2. So now evaluating the f function, we have 3, replace the x with negative 4, plus 2. That's negative 12 plus 2, which is negative 10.